Okay, so in our last section we talked about the formal definition for derivative, which is taking a limit of the difference quotient, and it can get a little messy as we do some of those. So in this section we're going to learn some shortcuts. So the first two shortcuts we have, remember if I have a function y equals f of x, whoops, sliding on me, y equals f of x, dy dx is equal to f prime of x represents the derivative. So we know if f of x is a constant, so it's equal to a constant number, again if I were to graph a constant number, so let's say y equals 5, we're looking for the derivative of that line when y equals 5. Well, the slope of that line is 0, so the derivative would equal 0. So anytime the function is a constant, we know our derivative equals 0. We don't have to go through the process of writing out our limit definition. If f of x equals x to a power, then the derivative is equal to nx to the n minus 1, where n was the original power. This is called the power rule. And we saw that when we found when f of x was equal to x squared, we found that the derivative was equal to 2x. So basically for the power rule, I'm taking the exponent, right? The exponent moved out front, and then 2 minus 1 is what I'm doing up in the new power, and so that's where I get 2x to the first, because 2 minus 1 is just 1. Alright, so I've given f of x equals 923, find f prime of x. Well again, 923 is a constant term, so this tells me that f prime of x is equal to 0. Okay, so now I have f of x equals x to the third, so I have an exponent, so this is my power rule. So f prime of x equals, remember the exponent moves to the front, so that's 3, x, and then I have to decrease that exponent by 1. So f prime of x here is equal to 3x squared. All right, given f of x equals x to the 12th, we're finding f prime of x. So f prime of x is equal to 12x to the 12 minus 1. So my derivative f prime of x is equal to 12x to the 11th. Now we can add a few more rules. So we can do a constant multiple rule. So if I have a constant times a function, the derivative is equal to the constant times the derivative of the actual function. We'll look at those in a minute. And then we also have the sum rule. If I'm taking the derivative of a sum or a difference of functions, I can take the derivative of each individual function and continue to add or subtract them. So here I have f of x is equal to 9x to the 7th. So this is 9 as a constant times x to the 7th. So my derivative, f prime of x, is equal to the constant 9 times the derivative of x to the 7th, which is 7x to the 6th. So my derivative here, f prime of x, is equal to 63x to the 6th. Now here I have a polynomial, f of x equals 2x cubed plus 5x minus 1. So essentially each of these terms is its own function, so I can think about taking the derivative of each term independently. Now I'm going to kind of put them all together. So f prime of x equals, in the first I have a constant 2 times a function x to the third, so this becomes 2 times 2x squared. In the second, so plus 5x, I have a constant times a function, so this would be 5 times x to the 0, and then minus 1, that's a constant, so the derivative there is 0, and then I just clean this up. So this would be 4x squared plus 5 is my derivative. Okay, so now I have f of x equals 1 divided by x, find f prime of x. So here we have to remember that we can rewrite the function as x to the negative first, and now I can use my power rule. So f prime of x is equal to negative 1 times x to the negative 1 minus 1. So this is equal to negative 1 x to the negative second, or I could write that as negative 1 over x squared. And we do a lot of practice with these. Calculus, one of our major skills that we need to do is be able to find our derivatives. So we have f of x equals x to the 5th plus 3x fourth plus x squared. So f prime of x is equal to 5x to the 4th. Now 3 times 4x to the 3rd plus 2x. And you don't have to write that step, that's okay. This would be 5x to the fourth plus 12x to the third plus 2x. Okay, this one we have f of x equals x plus 3 times the quantity x squared minus 7. Well, there is another rule we're going to learn in the next section, but right now we can't do that. So what we have to do is multiply that out. Double distribute. So f of x is really equal to x cubed minus 7x plus 3x squared minus 21. And now we know how to take that derivative. So f prime of x is equal to 3x squared minus 7 plus 6x, and then minus 21 would be minus 0. So my derivative is f prime of x is equal to 3x squared plus 6x minus 7. I just like to have my terms written in order. Okay, and this one, f of x equals x cubed minus 6x squared plus 8x divided by x squared minus 2x. Oh, that doesn't fit any of our rules, but remember we can simplify f of x. So I'm first do that. So f of x equals, I can factor an x out of the numerator. I'm left with x squared minus 6x plus 8. I can factor an x out of the denominator, and I'm left with x minus 2. My x's simplify, but I can keep factoring. X squared minus 6x plus 8 factors to x minus 4 times x minus 2. Still over x minus 2, so I can simplify my x minus 2's. So f of x is really just equal to x minus 4. So then to get my derivative, I can take the derivative of x minus 4, which would just be 1. So that scary looking function has a derivative of 1. All right, last example. It says given f of x equals 1/2 x to the fourth plus x. We want to find the equation of the tangent line at x equals 2. So the first thing I need to do is figure out what is my slope, find my derivative. So f prime of x is equal to 1/2 times 4x to the third plus 1. Clean that up, it becomes 2x cubed plus 1. So now we need to find the exact value of the derivative when x is 2, so I'm finding f prime of 2. So 2 times 2 to the third plus 1 is 2 times 8 plus 1, which is equal to 17. So now I know what the slope is. So if I want to find y equals mx plus b, I know my slope, I know the x value is 2, I need to figure out my y value is. So I also need to find f of 2 in the original function, so that's 1/2 times 2 to the fourth plus 2. So that's 1/2 times 16 plus 2, which is 8 plus 2, which is 10. So the actual point I'm using is 210. So now I can come back over here, and I can say to find the equation of my line, I'm going to say 10 equals my slope, which was 17, times 2 plus b. So 10 equals 34 plus b. So I know b equals negative 24, that's my y-intercept. So then I can actually write the equation of my line, which is y equals 17x minus 24. So that's the equation of the tangent line to the given function when x equals 2. Okay, so using the same function f of x equals 1/2 x to the fourth plus x, the second thing we want to figure out is for what values of x is the derivative equal to 0. Okay, well we already know what the derivative was. We said f prime of x was equal to 2x to the third plus 1. So we want to know when that is equal to 0. Okay, so I'm going to subtract 1. So I have negative 1 equals 2x to the third. I have negative 1/2 equals x to the third. And then I'm going to raise both powers to the both sides to the 1/3 power. So x to the third raised to the 1/3 is just x. And that means it's the cubed root of negative 1/2. So there is one x value where this would equal 0.